Hello everyone, thank you for joining again. In this video I'm going to show you another aspect of ArcMap, which is generating slope. Slope is very useful, especially when you're maybe calculating the USLE features or just trying to understand where you have steep or less steep areas in a watershed or in a municipal boundary, whatever you want. For this video I am using the Toronto Open data for the Toronto regional boundary, and this is a municipal boundary for Toronto, which is located in Ontario, Canada. The slope feature will allow us to either output the spatial distribution of slope in degrees or in percent. So to do this, we have our DEM, and you may recall in the last video we actually spent time to project it, and so I actually had the projected one open. And this is projected to UTM Zone 17 under NAD 1983 because we are in Toronto, Ontario, Canada. And if you're in a different region, definitely give me a shout and I'll definitely try to help you find the correct zone and the correct projection for you to use. So we're going to drag and drop this data set, and then we're going to just choose a location to write it. So I'm going to call this slope, and then I'm going to call it TO. Then I'm going to call CPR so we know that this was the projected data set. We have the option for degrees or percent rise. I'm going to choose percent rise, but you can choose whichever. Here's the explanation. Degrees will be with the little dot symbol at the end when you're reporting this, while percent rise is a percentage. And so my Z factor, I'm going to leave as 1 because I don't want to exaggerate it, but you are welcome to do so. And this will definitely make your map more eye-popping. So we're going to just press OK. And here's our foreground processing, and it's very, very fast. And there you have it, your map. So what you want to do with this map is you would want to reclassify it. So just like other tutorials, you're basically going to reclassify this just like a vector dataset and choose your breaks. I do like the natural breaks here, but I don't want 9 different classes, so probably we're going to take it down to maybe 5 different classes. We can see that slopes pretty much over 10 are almost irrelevant, so we can actually take it down to 3 classes, because when you're doing any kind of ground truthing or anything, you may want to make a reference of what is a good slope, what is a bad slope, and anything greater than 10 would be quite big. So we're going to just do it like that, and then we can just now relabel it. Less than 3, 3 to 10, and then 10 and greater. And then in our legend, when we make a map, we would then put a reference that this is in percent. And there you have it, an even cleaner map of just showing your slope. And now we can see that if we wanted to build over here, we may have trouble because the slope is too steep. Okay, and over here we have really high slope, and this may maybe generate microclimates, who knows. So it's time for you to have some fun and investigate and give it a try. You'll also notice the dataset is quite pixelated because we are using a very coarse dataset just to make the video run a little faster. So definitely give it a try with a finer dataset. And there you have it, using the slope function in ArcMap, using a DEM, and this DEM was attained from GeoBase, and then using the Toronto Open Data regional boundary. Give it a try. All the data is free and accessible to you. Thank you for watching.